Hello, this is Tom Hollowell from 321 Gang, and we're here today for a session on leveraging FinOps for AI. It's presented by Stephen Old, the head of FinOps and GreenOps at Synyega. I'm your host, Tom Hollowell, and I'm from 321 Gang. So, a little bit about the gang. We're members of the FinOps Foundation, TBM Council. We're an IBM partner specializing in FinOps, DevOps, TBM, and more. We offer training, consulting, migration, implementation. We're a sponsor of the TBM conference in 2025, November 10th through 12th in Miami, Florida. We have a few free passes, so contact us if you're interested. We offer IBM solutions both direct as well as through the IBM or the AWS marketplace. I'm not going to spend much time on what we call the rainbow slide. So it's just a slide of the various different solutions we offer from both IBM and other organizations. So a little bit about Stephen Old. So Stephen has been involved in FinOps for over 9 years. He's currently head of FinOps and GreenOps for Synyega. Synyega is a UK-based FinOps, GreenOps, AI, and ITAM consultancy. He's the co-host of the FinOps Guy podcast, host of Faces of FinOps, a contributor to the FinOps framework, and he's a highly certified FinOps practitioner. The other thing he also has roughly 12,000 followers on LinkedIn, which means he's a pretty big deal. A lot. But with that, I'm going to turn it over to Stephen, and I'm going to be the page turner.
Thank you very much. Thank you so much for having me to start with. And we're gonna go through a few things today. But I'm actually going to start with a little bit of view of the landscape. And I think a lot of people talk to us about AI and just assume that we know a lot more than we do. And the first thing to realize, there's a bunch of ways of buying. Right. And that's really worth it. Because everyone can talk about FinOps for AI and all these kind of things. We need to just start with the idea of how is this going into my organization? Because we're trying to understand how we're going to deliver value against it, right? But where's it going to get? Well, first we've got cloud/PaaS services. So when you're buying something as a platform as service, so OpenAI, DeepSeek, Anthropic, and if you're building AI services, you may well be using this. I can just add to that later since the Bible. Most likely the way people are interacting with it are going to SaaS. So it might be that you've got Copilot that work, or that you're buying ChatGPT yourself or Claude. And depending on what you're doing, you might use different things. And that's something to also learn. And this is the right models and the right service to the right thing. You might be building your own, but you might be using a basis of a model like Face or OpenAI. And then finally, you might have or most likely, in fact, almost certainly, if your organization gets into hybrid, into AI, it will be hybrid. You will have people who have a user-based service and then a cloud-based service or building your own. And one of the things I would just want to bring up here is you probably buy all of these different ways, and it is quite likely that those going to different teams. People talked about shadow IT and cloud back in the day. People buy things on credit cards. I will promise you, repeating the organization who are buying SaaS subscriptions for AI tools that you probably don't know about. And they're using small in their roles. And that's not them trying to be malicious, it's because they can find they can do things better. So having a strategy as an organization on actually allows you to have access to these tools means you can leverage better pricing, etc. Right, let's skip on from that. Hopefully that is obvious enough. The next thing is we want to talk about FinOps. So I mentioned it briefly earlier. FinOps is around demonstrating the value from technology. But the huge problem they are is understanding the value. And this is for a multitude of reasons. We'll go into this later on. But one of the key parts of that being, well, what are you replacing or what are you changing? If it's a brand new thing, it might not be that hard to measure because it's a case of what value is this new thing bringing into my organization. But if it's replacing processes, are you tracking the cost of those processes before? You're moving a cost possibly from people to a subscription or whatever it might be, the way you're paying for it, there's so many ways of doing it. And then that person might be then going off and doing something else, which is more valuable to you, hence why you're doing it. Are you measuring any of that? And so a lot of the problem I see is that people don't free measure what they are augmenting or replacing. And that might say, well, we haven't started that. Does that mean we have to start doing that before we can start doing the AI stuff? No, do it while you're building it. This isn't going to be an instant thing. Start measuring these things now. If you have an idea, if you're starting to build out the models, we'll talk about more that later on, that is going to take some time. So while you are building out your AI internally, which you might be doing for governance reasons, etc., start trying to measure these things a bit better so you can understand and set best. It should be part of your plan in invented FinOps. One of the things that I think people hold in FinOps at times is that it is a reactive thing. Well, planning and estimating on the core FinOps capabilities isn't about that at all. And better planning and estimating, better understanding of the value you're trying to achieve, saying those are the forecasts, is critical. And understanding the cost of doing nothing. I used to talk about that a lot in the early cloud transformation stage. That's not my background. It has never been truer than when we talk about it. Right. So let's start talking about some of the types of AI. Because I think that's really interesting. So a lot of things get called AI now that maybe didn't before. Traditional and predictive AI, that was called machine learning. That's what we used to call that. And it was using statistical models to predict outcomes from data. So forecasting on detection, those kind of things. I've heard of that. Now, I just want to have a little thing. I made some notes around the compute implications. It was quite compute intensive doing the initial training. But relatively like for the reuse of it, the inference, we're talking about inference. So generative AI, that was the next thing on people really start talking about. That creates new concepts, right? And that could be text, it could be images, it could be code that's based on learned patterns over time. ChatGPT, DALL-E, Copilot, Midjourney. Now, the explanation of what's different between generative AI and multimodal cloud goes for me. This has a huge impact on compute the training. Really hard, because you're training it to huge data that you try to get to learn so much so that it can answer that sort of thing. And there is a website called savethee.ar. Just a parody website kind of saying we need to stop leaving the lights on, because every time we leave the light on, it's taking power away from AI. We need to ration how much water we drink, because it's taking away from AI. And I think you'll be gobsmacked to understand the power and water implications of that. So go have a look at that. But a huge amount of that is in the training initiative. I've got a slide later on and breaks it down a bit better. RAG, retrieval and augmented generation. So this is combining generative AI with a search and retrieval layer for factual RAG. So this can be enterprise Q&As, and this could be a knowledge assistant. So I built something based on a small language model for this, which was answering questions about Microsoft license. And so I took all the Microsoft licensing data, I broke it up into a vector database, and then I do it. Now the beauty of that is actually your training so that's largely already existing. So its own training cost is quite low in terms of the compute, but it has a much higher inference almost. So inference, which we'll talk about later on, is where we are asking the questions, and it's kind of continually building on that. It's going to be higher because of we're asking to start a different thing. But it talks about, if you believe what's out there, that the training cost is less. That is not entirely true. I will talk about this more in detail on the future slide. Because it's built on the back of generative AI and other models, which, as you can see in this, have extremely high compute training. So just because the additional of that doesn't have much stuff, doesn't mean that there wasn't highly expensive compute required to train. It's just that was the previous stage. So interestingly enough, these different types of AI are actually largely built on top of each other. Agentic AI or AI agents is a perfect example of that. It illustrates using action using multiple AI calls and tools to achieve an output. So it goes in, it's like a flow of AIs working in different models. It's like autonomous assistants, workflow bots, Copilot, etc., those kind of things. And again, it says about light training. That's because it stands on the shoulders of those other models we talked about. But it has a really high inference and time orchestration process. It's a load of things hitting each other, and it's far more complicated. And that's why it can do far more brilliant things. And therefore, you have a different cost. So in a later slide, we'll go through the stages of AI. You'll understand that we'll have high costs for this because you're actually adding on top of each other. Multimodal AI. This is where we are getting multiple types of outputs. And so ChatGPT-4 is a great example of that, launching with Claude and Gemini, where you can get text or visual or audio can come out of that. So it can do more than one thing. That's why it's slightly different for kids. Large training and inference due to the complexity of the architecture just too so thick. So it's high and high. And then finally, edge and on-device AI, which runs locally on a device for privacy and speed. iPhone AI features, for example, camera optimization, co-pilots. It's got a low overall compute, but these are decentralized cost pattern, right? So it's death by 1,000 cuts. It's out there all over the place. And also a lot of the training has been essentially and could have been quite heavily used. Okay, next slide, please. And hopefully, that was new to people. I've never had anyone explain that to me. I thought it might be useful. So let's go slightly through the stages of it. So first, we have to collect the data. And one of the things I will tell you is the worst idea you can possibly have is to train on all of your data. It needs to be clean. You need to understand the question you're going to ask, and you need to collect the data to be able to do that. So that could be raw data, text, images, logs, code, whatever it might be that's going to answer. It could be sourced from the internet. It can be census. That's a great example of it, coming in from this. But it should be focused on what you are wanting to learn about. And that's why AI is that. Then you have a data model and a quality, which directly shapes the model's potential. So the better the quality and the tighter it is around the right things for it to try the answer you want. Better of it. Feature this is quite low in compute cost and intensity, which therefore all of these things, when I talk about the intensity, because it has an impact on cost and also. Then you have data preparation. This is cleaning, filtering, tokenization. This can also include feature engineering. Ever heard of feature engineering? That's where we may add like a column of data which we have used to build another view or another change. So we might compare two things together to create another line of feature engineering. And this ensures that the model learns accurately as unbiased patterns, right? So we do a load of prep, a load of cleansing, a load of cleaning. It's going to be quite intensive. Right? It is pre-processing, but it is going through large data sets. So again, the cleaning of the data is to start with, the more control you have over the cost and impact of that. Then you train the model. So it goes through that data, there's loads of computations. And interesting enough, what you do is you only, you run it against a portion of the data to train it, and then you test against the data. And you can choose the split, and that's kind of going into the complexities of how you really run AI. But the main thing is, this is really high compute. You then use that test data, and you fine tune, you bring data online, you get more specific tasks, and you keep working on the training and the model to get better at it, specifically what you're trying to work at. And that might mean sometimes you go through some of the stages, you add some additional features, etc. And it tailors general intelligence to stay for domain specific use cases versus it's making it tighter around what you want. And this is really hard for people, generally not doing anywhere near as long as you're doing the training. That's one of the key things. So while it's high level compute, it's over a short time. And time's been really important on this. I'm going to talk about that on a later slide because I've built a model around how I run FinOps for AI, and time is really actually critical. How we view how we do this. So we then have inference or serving. So this is the trained model generates responses or predictions for users. So this is the interaction. This is what you'll largely use. And this converts the training into practical value. So this is one of the most important things. And I've modeled on these slides. There's something called the levelized cost of AI, which was come out with, I saw in a paper from Cornell in August, which I can't believe it's already 2 months ago. But inferences are mainly the denominator about how you decide value on facts is the amount of actions that are taken. Right. This is moderate to high, depending on the volume, how wells and the questions we asked, that kind of stuff. And it's continuous. This is your long tail, right? And that's really key. And then really quickly, I'll just talk about the last couple. As we talked about a little bit earlier, for retrieval or RAG layer. So this is not related on top, which has an external search or vector database. Vector database are really important in how we handle some kind of aspects of models. And this reduces hallucinations, improves accuracy. We're kind of putting it around a more confined data set. And this is moderate. I think you can actually do RAG in a pretty efficient way. But it has an extra per query cost. So we're talking about like an inference piece, or adding a bit on top of that. But it doesn't feel like within the having the same training costs. But remember, the training has been done before this. And so while people kind of talk about RAG mapping that, it's because it's built on the shoulders of others. Orchestration or agentic AI, this is using loops and all that kind of stuff. We talked about that previously. This is really hard per task. There's a load of complexity going on. So that again looks like it's in the tail, and I'll show a graph in a minute. But that's all because it's still one of the training and the complexity of that. And finally, optimization and monitoring. We need to look at this over time. Arguably, compared to most of these others, that's a relatively light cost, but it's going up for everyone. So these are the different things that are breaking down our costs in a different time. So we tap onto the next slide. I've kind of put together a little understanding the different types of model and how they do over time, right? And hopefully the context I've given you will help some of this make sense. So traditional ML, which is our blue line at the bottom, arguably runs for you train a model and specific data set that's usually quite lightweight. You'll ask a few things, but you'll be building it for a purpose, which would be a prediction. Right, that's slightly different. So it runs, I think it's slightly less like that, but that's kind of how the data. Excuse me for my little part. Generative AI, look at how different that pattern is. Look at that huge compute intensity that if you just looked at this in isolation around training demand, it's massive. And then you see that it balances out through inference and orchestration, it drops out again. Then we have RAG, really low training. But why has it got really low training? So we've already paid for the training in the creation of the models that RAG is running on top of. And then it has quite a bit of fine tuning, but there's a lot of fine tuning based into RAG. And then the inference has a higher cost, like we talked about previously. And then finally, agentic. It has a low cost initially, but this continues going up because it's more and more complex over time. And the more things you ask it to be, the more confident it is, the higher it gets. That's fine. We can back on to the next slide. So what did I try to do to answer this? I built this 2.5 years ago when some big enterprises started looking at, they came to me and said, Steve, this first, a lot of people call me Steve, how do I avoid burning my money on AI? And I asked them, well, what do you need to learn? And they said, we don't know yet. I say, okay, well, what data sets should we start looking at? All of it. We kept all of our data for years. And I said, okay, the two answers you give me are the exact opposite answers to what you want to do if you don't want to burn your money on it. You need to understand what you want to learn, and you need to understand what data set gets you there. Talked about it earlier. The better the data going into the model, the more specific it is, the tighter your training, the tighter your tuning, and therefore your compute costs for that training. And the compute cost for the inferences is less because the inference is simpler because it's working on a model that is more suited to the question. Hopefully that makes sense based on the bits we've done so far. So I built this as a model to try to help explain to those people what it meant. So I think we can click through the slides. I used to do it all as one slide. I've broken it apart to make a bit more sense. So the foundations are absolutely critical. I cannot explain that enough. What is the value of the project? What does success look like? What is the ROI? What's the impact of the security risk? Because you're going to be putting data around here and you're going to be building on top of data. Are you allowed to? Do you want something having this data that can then create answers based on it? You need to really understand what's going into this data. And then you need to track these KPIs. So you need to understand what the budget is, the forecast is, the creation of disabilities. That's the top layer. What's my pane of glass? And then under that, what is my use case? Define what we're trying to achieve. How do we measure it? When we run it, we then need to review it. One of the things that goes most commonly wrong, in my view, in FinOps is that we don't self-evaluate. When we create a design for something, it goes and gets built. It's probably by the end, nothing like that design. And then we don't sit down and kind of go, how did we get that design wrong? How do we improve our cost estimates in future? We've got to be doing that. We've got to be constantly learning, because the numbers when we're talking about AI quickly go up, right? So we need to learn greatly. We need to self-evaluate. We need to, every time we build a model, every time we start a project, we have to take the learnings from previous ones to get as accurate as possible. Because, as we talked about earlier, we're building a business case based on an ROI that can be really challenging. We don't know what the ROI looks like because you don't know what the cost of doing nothing is. So hopefully we've been building that into this cycle as we're doing it anyway. But we more accurate than we can get our cost estimations, etc. The better and more likely we are to have a more successful. Right, next slide, please. Okay, so the critical part of this is the data we talked about and the architecture around that. And to an extent, the services, which ones have been used where, and so we'll focus a little bit more on the data as you watch this. But firstly, what do we actually need? Do we need AI? Do we need AI? Do we need ML, agentic automation? And that's one interesting thing. A lot of people are calling AI, things AI, but actually maybe there's automation. And that's what we used to call it, or just an algorithm. Like AI has taken over a lot of things. But automating things is not AI. That's the thing. What data should we train? Really critical. What are we wanting to learn? What data are we going to have? What is the format of that data? How easy is that to query? How easy is it to take the answer? How regularly should we train? How often is the data set going to have changed enough that we should retrain our model? And that is really critical to what we should be doing and how we should be doing. That's the key part of how we build the service architecture. Where should we run these services? Are we going to run them in the cloud? Are we going to outsource it to a service? Are we going to run it on premises? And interestingly, cloud is one of those use cases, AI is one of those use cases where that really needs to be thought about. You might be able to run this cheaper on-prem. Essentially, you may want to have that control. And then what's the carbon and cost impact of those choices? Do you want to run it on-prem because you want to have more control over it? But actually, you don't have the necessary equipment there, so you're going to have to pay loads of money on that, and therefore that's going to have a huge cost. Either it's the front cost, you're going to have to improve your network, whatever it might be. Have a real look at the total cost that are going into this. And one of the key things I'll briefly mention is that, so for example, about time. Okay. How quickly do you really need this? And that's really critical because that helps make that decision of where you should run these services. If you need to know it really quickly and you have the load structure, that tells you put out source code that goes into a public cloud provider. But that makes sense. But how time critical is training? When we talk about the cloud, we often talk about, if you just click onto the next slide, we talk about being abundant and, this one's critical in large. Yeah. We're talking about being never ending. I can tell you it doesn't. I hit the value, use all the spare. I was part of the project, used all the spare GPUs in all three major cloud providers at the same time in every region. Well, it cost a lot of money, but we did hit the edge. In this for Earth Science lecture. So it isn't never ending, but it certainly kills it. You can stretch a massive way, and so you can run things quickly, much quicker than you'd be able to run on premises, and on demand. But back in the day, I don't know if anyone ever did back-end computing at or necessarily high performance computing requirements at like the academia level. People used to run high performance computer clusters, right? Supercomputers. And what you do when you want to run carbon experiment, you would book a slot. And because it had a limited capacity, it's a huge capacity, things would run in series rather than parallel. So if you imagine at the moment, if you wanted to run 3 models in the cloud, we'd probably run them all at the same time, wouldn't really pay attention to it, just run them and all separate and all different. But if you haven't got a massive time constraint on it, If you're actually willing to stretch out the time while you're doing your other research with the learning, then is constraint a bad thing? Or does constraint actually allow us, if we've got enough workloads over time, could we work out what the level of usage we need is that we could run things in series with the amount of models we're going to rerun and all this, and run it a bit like we used to with a supercomputer? And when we do that, therefore, could we commit to those resources that they are doing? And hey, I feel above it, fine, and get a discount for them. People don't really think about rate optimization when it comes to ML and AI and stuff because of such a huge upfront piece. And then you think, oh, the rest is lower. But actually, there's a choice around the speed at which you train those models, and you could elongate them out, allowing you to get commitment discounts and run things in series. But that only makes sense if you look at the time and the scale. And I've never seen anyone give that piece of advice about myself. And you do need to be an enterprise scale or certainly a very heavy AI user to do it. But even if that just makes one person who listens to this think about it and run more efficiently, you just say something from really doing it. So I just wanted to check that out. Right size, you're used to this, right? And so these are the pillars of potential safety. It's one of the most understood concepts. But we need to consider how best to resource our training on instances VMs. The most common mistake is sizing, is the amount of data as well. Like people don't think to shrink the data to get it right. So I think right sizing covers in there as well. Let's train on the right thing. And if you train on too large data set, it can cause massive bloat, reduces accuracy, and if you do it correctly, then you can increase the speed on training it. Right. So if you do shrink it down. So by doing it wrong, you actually are proliferating a lot more issues. And all of these issues cost dollars, right? And that's training bits. Okay, next one, please. Model efficiency. So this is new for most of the world, right? It's a different chapter. There are lots of models, and it takes time to understand the right model for the right use case. You're not going to get it right first time, right? Use your thing you're most comfortable with first time and learn over time. I would talk about the lessons learned, the continuous iteration is key. There is some guidance out there. You can get, people have a feel for what's out there. There are more and more people learning more and more things as to how you may track it. But you pick the best tool and understand the parameters to run that effect. It might be running your own GPT. It might be this should be handled by SaaS because this is doing generic stuff. It doesn't need our data model. But let's have that kind of considered approach around using the right thing in the right place. Does it need to be agentic? Could you build an SLM to feed an LLM? Small language model, large one. So I came up with the concept, and when I spoke to an AI person, I said, "This is the saying I'm not an AI person." We often want to follow the answers we know, and also we want to use them tools as possible. That's the problem with engineers and architects like me. And so I came with the concept of something to do around, I mentioned earlier, around asking a bot questions around Microsoft licensing. And the guy says, this needs to be agentic. We'll use that. I built a small language model, and I passed the question or the response to the question. So the question I asked a small language model, which is based on a RAG response, but very similar. It's a very simply trained model that I trained on a Spot instance. The single one, because I kept my data set so small, it cost $20, right? And then it fed a large language model, the GPT in this case, to make more sense of the answer to come back in a better state. Because what happens behind the scenes is, you imagine, I've split all this data into chunks that have gone into a vector database. No need to understand that in too much detail. But just imagine I've chunked things into like 500 characters. And when it asks the question, it works out which of those chunks is most likely to know the answer. And then I feed those top 5 through the large language model, which I've not trained, and therefore I'm just paying a consumption. So I've trained one, I've paid the cost for that. The other one, I'm just paying a consumption cost for the amount of tokens to try using. And then they get an answer which is more verbose and more clear to them than they would if they just got those chunks right. That cost me a fraction. Literally a fraction of what it cost me to do an energetic way. Because that's all I needed. Right tool, right job. I'm going to get it wrong a few times, so that's this sometimes. But really, use the minimum you need. You can always build on top of that, right? You can use that as part of your agentic workflows in time. But for each individual thing, start small. How you put turn later, how you put turn later. And do you want to train the AI in use? That's an interesting one, right? One of the reasons I built my thing that way is actually the GPT I use didn't get trained when I was just feeding it from my SLM. If I had built it another way, I'd have basically been using my data, would have been training one of the third-party tools. And actually, this had a lot of stuff I wanted to keep behind the scenes because the our team had done written. So I kept it behind that and it stopped me basically training it. And that's just something to think about. It's to do with security. And again, that's not something that most people will get their heads around the future, but it doesn't need to be that complicated. Just do some research on what to use. Be willing to get wrong, but start as simple as you can rather than going for the complex thing because it's what CEOs are talking about at the golf course. We need to use agentic AI. Well, actually, if I tell you I could for $25 instead of $10,000, do you want me to give that a go for less? Quickly, you can get a positive response. And the final column is request efficiency. So I ran a little example of this quite recent. So hopefully most people here have used Copilot or ChatGPT or Claude. And so you were used to this idea that you ask a question and like it's frame that question. It's not a problem when you're paying per user. But when you're paying per token is basis happening behind the scenes. You are profitable by tokens, by the way, those services. And you don't feel the direct cost, but when you start slowing down, and sometimes you get like outputs that reduce the say business run out tokens. It's because of something called context. And what happens is you ask a first question. So I say, how many tokens does this request user? And he comes back and says 20. And then I asked her a question saying, but it actually says a bit more about it. It's user 20. It's broken down by this and this and this and this. But it gives me a really lovely answer. So that's what it's trying to do. That's what generative AI does. It's trying to give you a really succinct answer. The way it works behind the scenes is it fits for most like. If I then say, and now how many tokens is this token in the same chat? It uses all of the tokens from before, all that stuff it's got. It takes that into context and passes that through. So I've gone from like 20 in my first one to 400 in my second, right? And what does that mean? Well, if you train people how to do the quests well, they can probably get the answer within 1 or 2. If you don't train people, studies have shown it can use up to 20 queries to get to the same answer that someone who's trained can get to one. Now I've given you an idea about how 2 queries compare. 20 to 400 tokens, right? Imagine when you get to 20. It isn't 20 times worse. It is a horrific multiplier worse. And you start caring about that when you pay by the token. Now, you pay by chunks of tokens, what I call that tokens. But when you put that across the enterprise, this is death by 1,000 cuts. This is where you get really hurt. It's a sting in the tail. It's that bit that's mentally cheaper because you pay for all of the bit of front line of the training. You need to train people how to ask the right questions. And while they're still cheap, they're really cheap. Okay. That is that. And that all together, with that kind of basis of thinking about the use case, defining it, measuring it, running it, reviewing it, learning continuously, which helps you feed into your forecast, your budget, and you're viewing and you're keeping an eye on these things at all times. You don't just let these things go because that's how you start earning dollars, right? If you bear in mind, and it's all right, the scheduling resources and commitment discounts will not apply to somebody fine. You still need to be thinking about your service, your data architecture. You still need to be thinking about right size, your data and your compute and your services core. You need to think about using the right thing for the right job. And train the models to the right regularity and train that as efficient as you can, making fine tuning as efficient as you can. And you need to make sure that people are using. You could change the quest efficiency to users, because that can be a big part of the cost. So that is the kind of model I came up with 2.5 years ago. It is still as true now as it was when I created it. And it's still something that I think people don't think enough about because they are racing into AR. This is how you take a FinOps mindset, you buy it against this, but you have that bit of extra time and knowledge. And the final piece of the jigsaw, oh wow, that's an echo transition, isn't it? Is that you also have to consider around SaaS user license management. It could be like if you're sat in FinOps listening to this, or if you're even sat as an engineer listening to this, do you ever speak to your ITAM team who look after like 365? It's licenses like that. They are the people who understand how to use it. They have the processes like how you onboard, offboard, all this kind of stuff. And they need to be on this journey. They need to understand the impacts of that. And then if you're using the PaaS services, you put a consumption on top of that. It should be token based, etc. That's a bit more like cloud. Who looks after that? And one of the things we find in FinOps for AI is more than anywhere else I've seen it. This is where collaboration across FinOps, procurement, engineering, ITAM is really critical because we're using all sorts of different FinOps scopes across different types of costs that are coming out to really meet one type of service, or feels like one type of service. Hopefully what we've learned through this is it's not one type of service. There's a bunch of different types of AI. You purchase them in different ways. You need to use the right one for the right job. And that is a team effort. No one person can do that well, in my view. And that, hopefully, is 40 minutes of useful learning around how to apply FinOps to AI.
Yeah, I'm just checking to see if we've got any questions in the chat. If you do have questions, you can ask them there. I'm not sure that if we've got the capability to open up the mic. So if you have any questions, ask them now and let us know.
Feel free to ask about any part of the talk, because there's a lot of information there. So if I haven't explained to anyone, even if it's early on, ask that question. I don't mind. It's my job to make it make sense. And if I have, that's my fault.
So far, I don't see any questions coming in. Let's give it another minute. And while we're waiting to see, if you're interested in learning more about this topic and it's exploring how FinOps for AI can bring visibility and control costs, some of the stuff that Stephen talked about today, contact us, 321 Gang, we're in the US, or Synyega in the UK, and I believe they handle some of the other parts of Europe as well. My email address is here, Stephen's is here, so if you've got questions, reach out to one or the other of us, depending on where you're located, and we can provide more information. But Stephen, I don't see any questions coming up, so I think we're good.
It's done a great job.
I appreciate it. Thank you very much for your time today, everybody, and thanks, Stephen.
Thank you, Sam. It's been a pleasure.
Yep.